Hey guys, this is a video about the electrochemical series. This is just a brief introduction, so I hope you'll stick to the end. Stay tuned. So of course the obvious question is, what is the electrochemical series? The electrochemical series is basically an arrangement of the metals according to their electropositivity. So let's look at the electrochemical series. This is the arrangement from potassium right down to gold. Now there is a simple way to remember this. I did not come up with this, but this is how I remember it anyway. Please stop calling me a zebra. Instead, try learning how copper saved gold. So this, the first letters correspond to the first letter of the metal. So potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen, copper, silver and gold. Hydrogen is included here, although it's not a metal, because sometimes it's useful to know the positions of metals with respect to hydrogen. So this list is arranged according to the electropositivity of the metals. The most electropositive metals are positioned on the top and the least electropositive metals are at the bottom. So the higher the position on the electrochemical series, then the higher the electropositivity of the metal. For example, magnesium is more electropositive than tin. Likewise, lead is more electropositive than silver. So once again, electropositivity is the tendency of an element to lose an electron. When it loses an electron, it becomes positive because there is a surplus of positive charge. Minus 1 negative charge, now we have extra 1 positive charge. That's how it works. You should remember that metals are on the left side of the periodic table. The periodic table is arranged from metals, going from metals from the left all the way to non-metals on the right. So metals tend to have very few valence electrons. And so it is easier for metals to donate electrons to form the octet or duplet electron arrangement, which is what is desired because it is stable. That is why metals normally form positive ions by donating electrons. So here is the example of metals donating electrons. So potassium would donate 1 electron to form K plus because it's in group 1, it has 1 valence electron. Same goes to sodium. Magnesium is in group 2, so it donates 2 electrons. Calcium is in group 2, so it donates 2 electrons as well. More than half of the table consists of transition elements, so of course they may form more than one type of ion. But the key here is that they donate electrons to form ions. So let's compare a metal at the top of the table with a metal on the lower position of the table. Let's compare potassium with copper. So potassium is right up here. It is the most electropositive element in this electrochemical series. So potassium would donate 1 electron to form K plus ion, and copper is at the bottom here. Copper would donate 2 electrons to form copper 2 ion. Since potassium is at a higher position than copper, potassium is more electropositive than copper. So potassium metal has a stronger electropositivity compared to copper. Remember, this is all relative. It is all in comparison with one another. However, the ion formed here, the K plus ion that is formed, potassium ion that is formed, will have a weaker electronegativity than the copper 2 plus ion. Think about it like this. The potassium metal is more likely to donate the electron away. That means it is less likely to take it back. Copper is less likely to donate the electrons away. That means it is more likely to take it back. Now, this is the concept that is used when we are looking at the decomposition of ions in electrolysis. So the metals that are at the bottom of the electrochemical series will be chosen rather than those that are higher up. The reason for this is because the decomposition happens to the ions of the metal, not the metal itself. So if the metal is lower down the electrochemical series, it means that it has a lower electropositivity. However, when it forms the ions will have a higher electronegativity, meaning that the ion that is formed from the metal that has low electropositivity will have a higher tendency to accept electrons compared to a more electropositive metal. Electropositivity is the tendency to donate electrons. Electronegativity is the opposite, is the tendency to gain electrons. Let's look at copper now. Copper does have a weaker electropositivity than potassium because it is lower than potassium in the electrochemical series. However, the copper 2 ion will have a stronger electronegativity than the K plus ion, meaning that if both copper ions and potassium ions were present in a solution, then the one that is more likely to accept electrons would be the copper 2 plus ions because it is more electronegative than the potassium ion. Generally, the more electropositive the metal, the higher its reactivity. Remember, chemical reactions are all about the movement of electrons. So if a metal is more likely, it has a higher tendency to donate electron, it also means that it is more reactive. The reactivity series of metal is very similar to the electrochemical series. In fact, it's almost the same. The position of hydrogen is different, but that we will cover in another video. I hope you've learned something. Please hit the like button if you have, and please subscribe if you haven't. I'll see you in the next video.